Hello, welcome back. Hope you had a nice restful weekend. And we are going to dive right into the next part of our EOC review. This is review part 2. This is review number 2. And this is the first part of that. So review 2, part 1. The notes are dated and also page numbered. And I want you to make sure that you are writing your name and date and your period number at the top. Do not forget that, please. Thank you very much. And let's go ahead and just get started. So the first topic here is going to be about relations and functions. So the first thing is that whether it's a relation or a function, you need to be able to decipher what domain and range are. So the first thing to know is that for a domain, that is what all the possible x values are, okay? And then the range would be all of the possible y values. And for a relation to be considered a function, that means you have to have no repeating x values. So none of the x values will repeat. And another way to do it is by just looking at the graph of all those points plotted out. If that passes the vertical line test, then it's a function. So we're going to fill in vertical line test here in this blank. Lovely. Okay, so let's look at some domain and range and to tell if it's a function or not. So on the first question here, we have a table of values. The x values, we're going to highlight those. The x values are across the top, and then we have our y values across the bottom. So the domain would be all of the x values that you see on this table. And I don't like how thin this pen is, so we're going to fix that right now. Okay, so the domain is going to be -1, 2, and 5. And I'm not writing this other -1 again because I already wrote it once, okay? And my range is going to be, and I probably should put these from least to greatest. So my range is going to be 0, 2, 3, and 7. And this is going to be not a function. And it's not a function because if you look, these two x values are repeated. So it is not considered a function. Okay, and let's take a look at the next problem. So all we have here are some points plotted on a coordinate plane. And so in order for us to figure out if this is a relation or a function, we need to sort of like look at these and make a table of values out of it. That would be probably the easiest way. So I'm going to make an x and a y table right next to this. And I'm going to just put some lines here so we can, how many points are there? 1, 2, there's five points. So I need to make sure I have 5 sections. 1, 2, 3, 4, 5. And let's fill that table in by looking at the points. So the first point right here, this one right here, is the x value is -3 and the y value is 2. So we have a -3 and a +2 for the y. The next one is -2, -2. The next one is -1, -1. I don't think this is not a point. Yeah, I just drew that by accident. Okay, this is a point, and this is 1, -1. And this is a point, and it is 4, 0, because there's 4 to the right and 0 up and down. So if I were to classify my domain with numbers, that would be -3, -2, 1, 1, and 4. Like this. And then we also want to talk about our range, which would be our y values. They are -2, -1, 0, and 2. And my question is this a function or not? And you can tell if any of the x values are repeated in this domain and they're not. So this is a function. Yes, this is a function. Okay, question number 3 is for you guys. On the left side, you have all the values that are in the domain, and then on the right side, you have all the values that are in the range. And I want you to write out the domain and the range and then figure out if it's a function or not. So I'm going to roll this page down. Let's make sure you can actually see this. Lovely. Okay. Now it becomes slightly more complicated because we don't have any points. All we have is actually like a graph, and the graph is already the line is continuous here, like it's already drawn in for us. So that would mean that this line that you see on this graph includes every single point that's happening here. Okay, so like there's hundreds and hundreds of points between the beginning and the end of this graph. So you can't take the same approach that we've been taking. Instead, what you're going to do is you're going to list the possible x values and the possible y values as it being a range between particular numbers. Okay, so the domain is going to be including. Oh wait, are there arrows? Yeah, there's arrows here. So that's even something else. The arrows. So let's draw a little thing. So the arrows. The arrows suggest that this curve that you see on this graph, it just continues on and on and on forever. And so that means that my x value, if I'm looking at the origin right here in the middle, my x value could be anything greater than 0. And they told you with these arrows, this graph is going to just continue and continue. And the same to the left, it's going to just go on and on and on forever. So that means that the domain would be all real numbers. Okay, that's what that symbol means. Remember, we did that in the last section. All real numbers. So x could be any real number. Any real number, and you'll be able to find a y value for that. Okay. The range, though, the range, according to what I can see on the graph here, appears to only be, it's only between, I'm going to switch colors so you can see this. The range seems to be between these two imaginary dotted lines I just drew. So there's doesn't appear to be any y values above or below the top and the bottom of this curve, the peak and the valley of this curve here. So the range is going to be, it's going to be -1, and then y could be anywhere inside of that range between -1 and +1. So that's what this notation means here. This range, the possible y values are between -1 and 1. Question, is this a function? Answer, yes. And the reason I know for sure is because I can do the vertical line test. So if I go to my graph and I just decide to draw vertical lines in like a bunch of different places here, here's a bunch of vertical lines. Do any of these green lines that I just drew, do they touch the graph, meaning the curve, more than once? And the answer is no. So yes, it passes. So it is a function. Okay, number 5, I want you to go ahead and decipher that. Remember that if it is a function or if it's not a function, you can still find a domain and range. Okay, so if this is a function, there's a domain and range. If you do the vertical line test and this is not a function, then you can still find the domain and the range. There needs to be answers for domain and range, whether the function question is yes or no. Okay, rolling the page down, we have a different topic and another topic to cover. Let's do this one in purple, why not? So this is function notation and evaluating functions. So what this says for number 1 is that the function of x is this. This is the rule you're going to follow, okay? So anytime, since the variable here is x, that's what this function is this variable x. The function of x is this rule, meaning anytime there's a value given for x, you're going to plug that in wherever you see an x inside of the function, okay? Another way to look at this is like, this is like an input. Whatever value you plug into there is going to allow you to substitute it into this rule and get an output. That's the whole idea behind functions, okay? So let's figure this out. If f, so this says find f of 5. So this means instead of x, we're going to have 5. Anytime you see an x, you're going to substitute that for a number 5. And since this function only has one variable, you'll be able to solve that and get a number, and that's the output that goes with 5. So another way to think about this is like, I'm putting my pen down. See this? I'm putting this down. I'm going away from the paper, so come away from the paper with me and just think this through, okay? If I work in a factory, and depending on what types of materials I put into this machine, I get a different output, right? So like, let's say it's, I got it. Here's a good example. Let's say it's like a clothing factory, and depending on how many yards of fabric you put in, the machine will automatically make you different types of garments. So like if I put 1 yard of fabric in, the machine will output to me, a mask. Okay. If I put 2 yards in, it'll make a bandana to go around my head. Okay. Do you see how like as I gradually increase the amount of fabric I'm giving, the larger the garments are that are coming out? If I put 3 yards in, it might make me a scarf that goes around my neck. If I put 5 yards of fabric in, it might make me a t-shirt. If I put 15 yards of fabric, it'll make me a whole pajama set, like a top and a bottom. That's the whole idea behind functions, is that your input that you're plugging into this function, it's going to produce something, and then it'll spit it out, and that'll be your output. Okay, that's the whole idea. So in this example, the machine that I'm plugging it into is negative x minus 7. And the thing I'm putting in is 5, and so I need to find out, if I put in 5, what does the machine put out for me at the end? So all I do is I put negative 5 minus 7. Now, I did that with parentheses, okay? And I want you to get used to doing that if you're not already, because the value could be negative that you plug in. And if this was negative 5, I just don't want you to mess any signs up or anything, and that's why I always use parentheses when I plug stuff into a function. So now I can solve this. This is negative 5 minus 7, and that's going to give me negative 12. Okay, so the input is 5, the output is negative 12. I'm going to do 3 with you, and then you guys are going to handle 2 and 4. Okay, so on number 3, let's label it, right? So this is our in. This is the machine. And then the output is what? Well, we don't know what the output is. We have to literally plug some stuff in first and find that out. So let's do that. I'm going to use blue here to do this. So they want me to do f of negative 4 minus f of 9. So this is 2 different things I'm going to have to do. First, I have to find out what's the output when I plug in negative 4, and what's the output when I plug in 9, and then I subtract that from the first one. So f of negative 4, make sure you can see this on this lovely page. Looks like you can. F of negative 4 means I'm doing 2 negative 4 squared minus negative 4. And then to solve this, we use order of operations. So negative 4 squared is going to be positive 16. So 2 times 16. And then minus 4, this multiplies to make a positive. So this is going to be plus 4. 2 times 16 is 32 plus 4. And that's going to give me 36. So the output when the input is negative 4 is 36. And then we also have to do f of 9, which is going to be 2 times 9 squared minus 9. That's 2 times 81 minus 9. 80 and 80 is 160. That's 162 minus 9. And 162 take away 9 is going to give me 153. So the output when the input is 9, I'm not sure why it drew my arrow so low here. Let's move this sucker up. There we go. Okay, the output is 153. Okay, so I need to take 36 minus 153 and get an answer, and that's going to give me minus 117, and that is my final result, okay? So that question was obviously a little more involved. Sometimes it is. The thing they're trying to make you understand here is how to plug stuff into a function and get the output, okay? You guys can handle 2 and 4, so go for it. I'm going to roll on to the next screen here. This is page 2, review 2, part 1, page 2. And the question says, find the range of the function. Here's the function right here. Ooh, let me move this over so you can, I think I zoomed too much. Okay. Find the range of the function if the domain is -2, 0, and 1. Okay, so let's put all of this together, right? So in a function, every value in the domain, so every possible x value, should have only one output, okay? So they're all ordered pairs, right? So if I plug in -2, I'm pointing to this on the screen here. If I plug in -2, I'm going to get a value. It's going to be a number. And then if I plug in 0, it's going to be a different value. And if I plug in 1, it's going to be a different value. And I know that it's going to be different and unique because it's a function. They told me it's f of x. It's function of x, okay? So in order for me to find the range, I need to plug in all these x's or these inputs and figure out what the outputs come out to. So let's figure them out. We're going to do f of -2 first. And when I plug in -2, I get -2 squared plus 4 times -2. So let's do -2 squared first. That's -4. And then we have plus, but we have 4 times -2. So plus -8. Keep calculating. You're going to get -4 minus 8. And -4 minus 8 is -12. Okay, so that's the first output. I will switch colors here and do f of 0. That will be -0 squared plus 4 times 0. Well, 0 squared is 0, so you can't have -0, so it's just 0. And then 4 times 0 is 0, so 0 plus 0 gives me 0. That's my next output. And then I have to do f of 1, which means I plug in 1. It's going to be -1 squared plus 4 times 1. So that's -1 plus 4. That's +3. So in summary, the range is going to be 0. No, I lied. It's going to be from smallest to greatest. So -12 is first, and then 0, and then 3. And there you go. Now I want you to do the same thing again for number 6. That one's going to be for you guys. And I'm going to roll on down to the, I believe, last topic of this review. Yep, this is the last topic. This one is about zeros of functions. So there's different ways to find this. If you have the graph already, then you can find the zeros by looking at exactly where the line passes through the x-axis, okay? And then the other way to do it, if you have the equation, is to set the equation equal to 0 and then solve for possible values of x. When we say a 0, we're looking for what is the input that you would plug into the function to give you an output of 0. Okay, if it's a straight line, then you're only going to have one possible answer. If it's a quadratic, meaning to the power of 2, you're going to have 2 possible real answers. And then if it was cubic, you'd have 3 real answers, and so on and so on. But we're only dealing with linear and quadratic, so let's do that. Number 1, the 1, 2, and 3 are really basic. All you're doing is just looking for where the graph crosses the x-axis. So on number 1, we'll use bright green for this, why not? It crosses the x-axis right here. So You have a 0. What's the x value? What's the x value when it crosses this axis? X value is 2. So that is the answer. That's the 0 of that function. I want you to do the same thing with 2 and 3. And keep in mind on number 3, there's going to be 2 answers, okay? Because this one has 2 places where it intersects the x-axis, okay? All right, so 4 through 9, this is the other way to do this problem where you have the function but not the graph, and you have to set it equal to 0. So let's do number 4 together. We're going to take 2x plus 2 and make it equal to 0. Let me get my x by itself, subtract 2 from both sides. 2x equals 2. Divide both sides by 2, and you get x equals 1. So x equals 1 is a 0 of this function. The way to look at this answer now is to say to yourself, if I plug in 1 to this function, then I should get 0. And I don't, because I just realized I made a mistake. So watch me now as I fix my mistake, okay? When I subtracted 2 from 0, that would be this part right here, okay? When I took away 2 from 0, my answer should have been -2 here, and I was going too fast and did not remember to put my negative, so don't you forget that. That makes my answer -1. So my 0 of this function is -1. Okay, so 5 you should be able to handle because it's just like 4. And then the rest of these are quadratic, so we're going to do them together. The first question I'll do with you is 6. You're going to take x squared plus 3x minus 40 and set it equal to 0. Now remember, okay, the way that you solve quadratic equations is different from how you do linear equations, okay? You do not just start moving stuff around to try and get x by itself. You're not going to be able to get x by itself because there's an x squared term and there's an x term, okay? The best thing that you can do here is you can actually factor this. So this is going to kind of take you to just a couple months ago when we were factoring. And before I explain the rest of this, I'm going to take a nice sip of my iced coffee from my Gators Tervis. Go Gators. Okay, so let's factor this. We're going to make 2 binomials, which are equal. We set the equation equal to 0 to find the zeros. And my first term here is just going to be x in both of these because x times x gives me x squared. If there was a number in front of this, like how in number 9 there's a number and in number 7 there's a number, we would need to, kind of figure out what to do with that, what multiplies to give me that number, and those would go in the front of these binomials. Okay, now I'm looking for 2 numbers that multiply to -40 and add to 3. And I already know what they are. It's 8 and 5. You just have to figure out the combination of what's plus and what's minus because they have to multiply to -40, which means one of them is going to be positive and the other one is going to be negative, okay? So if I have -8 and I add 5 to that, that's going to give me -3, which is not what I'm looking for. So instead, I need to have +8 and -5. -8 times -5 gives me my -40, so that's correct. And then +8 minus 5 gives me +3, which is what I want for my middle term. So I'm just going to get rid of that little line I just drew. Okay, so, all right. Remember we discussed before something called the zero product property. So what this is saying is that you have 2 things being multiplied here, right? You have this whole quantity, right, in the x plus 8 in parentheses. And then you also have this whole quantity, x minus 5 in parentheses. And those quantities are being multiplied by each other, and they equal 0. So what I'm saying is that in the zero product property, what that means is that one of these products, if one of these products is 0, the entire thing has to be 0, okay? Think about that in terms of numbers, right? If you had 0 times 4 times 6, right? It doesn't matter what 6 and 4 multiply to, okay? It doesn't matter that this is 24, because even if you were to solve that, you still have 0, right? And because 0 is a product, the answer is going to be 0 no matter what. You can have 0 times 1 times 2 times 3 times 4 times 5 times 1,000 times 40. It doesn't matter how many other things are in there. If all these things are being multiplied and there's a 0 in there, the answer is going to be 0. That's what the zero product property says. So if you go back to this question, right, it doesn't matter what these are individually. If one of them is equal to 0, the whole thing will equal 0. So I can use this to my advantage, okay? Because if I find out what value of x makes, let's switch colors. If I find out what value of x makes this parentheses 0, then I've solved my equation, okay, for one of my answers. If I find out what value of x makes this equal to 0, I've also solved the equation. Those are my two things I have to look for now. Because if I know, you can look at these and figure them out in your head, right? Like if x is 5, 5 minus 5 is 0, and that therefore makes the other thing 0, because it's going to be 0 times 8 plus 5, which is 13. 0 times 13 is 0. So it works. The answer works, all right? So the way you do this is you take the first thing, make it equal 0. Take the second thing, make it equal 0, and figure out what the two solutions are. So if you take away 8 from both sides, you get x equals negative 8. And on the other one, you have to add 5 to both sides, and you get x equals 5. The two possible solutions are x equals 5 and x equals negative 8. If you plug in either one of those back into this equation here, okay, your answer is going to be 0. These are the zeros of this function because they make the output 0, okay? All right, we have just one more problem to work on as an example here. This is going to be f of x equals 2x squared minus 72. And I think something that I can actually do before I even move on here is I can factor out a 2. So this is actually 2x squared minus 36. Now, there's a reason I did this. And the reason I did this is because it's really not easy to factor what I started with here. But by playing with the numbers a little bit, I can tell that there is a difference of 2 perfect squares, right? If I factor out that 2. Okay, now remember when you have the difference of squares, okay, difference of 2 squares, this is a special factoring pattern that we can look at, all right? The difference of 2 squares, you have to figure out, I'm going to use a different color, what's A and what's B, and the pattern that you factor it to is A plus B and A minus B. So this square root is A, and this square root is B. So the square root of x squared is x, and the square root of 36 is 6. And therefore, this entire thing can be factored, okay, as 2x plus 6 and x minus 6, okay? And the whole point of doing this problem is that we're supposed to set it to 0, right? And find out what values of x make this function equal 0. So let's go ahead and solve this now. And I'm actually probably going to run out of room, so let me just erase all this that I did at the bottom. Get rid of all this previous example. Okay, so let's keep going. So divide both sides by 2. And you get x plus 6, x minus 6 equals 0. And just like what we did before in number 6, we want to set each factor equal to 0 to find out what the values will be. Or you can just look at these and you can tell like it's the opposite. So like it's going to be negative 6 and plus 6. But I'll work it out. So it'll be x plus 6 is 0 and x minus 6 is 0. So x is negative 6 and x is positive 6. And those are going to be your solutions. The other thing you could do, let's make sure you can read that. Yep. The other thing you could do is you could write your answer as x equals plus or minus 6. Choice is yours, doesn't matter. Okay, so I think I told you about 5 earlier. Okay, so 8 and 9 are 2 more examples of quadratic that you need to solve. And that's going to be it for the notes for Review 2, Part 1. So remember, you'll be getting a grade for doing the examples that we did together. So I want to see all these examples written out. And then you'll have a separate grade for doing the practice problems on here. We're going to call that classwork, quote unquote. And then there will also be a Delta Math assignment that goes along with this, and that's another grade. Okay, so please make sure you're doing all 3 components, all right? If you have any questions about what we've done in this video today, please feel free to come to my office hours. Those are Tuesdays and Thursdays, 10:30 to 1:30. And until next time, I will see you guys later. Bye-bye.